He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
Kia ora and a very big welcome to episode 50 of Elemental from RNZ. We are marking the International Year of the Periodic Table by looking at all the chemical elements, no matter how common or how obscure. I'm Alison Balance.
And I'm Allan Blackman from the Auckland University of Technology. And today, speaking of obscure, we are going to talk about neodymium.
You can say that again. Take it away.
I shall. So, the vital statistics for this element, the name comes from the Greek Neodydmos, and that means new twin. And we'll talk about why in a minute. Chemical symbol Nd, atomic number 60, and that puts it in the lanthanoid elements, and it was discovered in 1885. So we have covered many lanthanoid elements up until now on Elemental, and generally we find that they have got a long history, and neodymium is no different in that respect. So let's go through and find out how it got its slightly unusual name. So in 1841, a guy by the name of Mosander isolated a new oxide, and he thought that it contained a new element, and so he called it Neodymium. And the reason he called it that was because he thought it was a twin brother of lanthanum, if you remember our lanthanum episode. So this is where the twin bit comes from. And alas, he was wrong. Well, he was partially right, and I guess partially wrong, because by 1885, this new oxide was in fact shown to contain 4 elements, not the one of which was neodymium, and that translates as neodymium.
But didymium as an element name, I think, has actually disappeared, but we still have a new didymium.
Yeah, and this is something that I didn't know, I'd have to say, so thank you, Alison, for this, that didymium was in fact on Mendeleev's original periodic table back in 1869, and that makes it the only element that was on the original periodic table that now no longer appears on modern versions of the table.
Which I have to say is pretty amazing that there's only one that was wrong.
Yeah, that's pretty cool. I think, old Mendeleev was a bit of a genius. I think he got most things right there.
Yeah, it's been a while since we've acknowledged that, so yeah.
Yes, here. The whole new twin thing, the other elements there was, we've got praseodymium, and that was the other element that the Austrian chemist Baron Karl Auer von Welsbach discovered at the same time as a result of analysing this metal that everyone was calling didymium. So didymium was actually made up of neodymium and praseodymium.
Which we'll get to eventually.
We will. So von Welsbach studied this using spectroscopic analysis, looking at the type of radiation that heated samples of these gave off. However, the element wasn't actually isolated in relatively pure form until 1925.
That took a few years then?
Yeah, everything seemed to take a few years with the lanthanoids.
Tortuous. We've used that word about them before.
Yes, I like that word, yes. Now, neodymium, perhaps not an element that many people have heard of, but in fact it's the second most abundant of the lanthanoids, and that makes it pretty much as abundant as copper in the Earth's crust, which everyone's heard of.
So once again, is this something that, although we've never heard of it, it's going to turn out to be all around us?
It is quite well known for a lanthanoid, certainly over the last sort of 20 or 30 years, as many people, apart from you, Alison, clearly.
I can't name anything that's got neodymium in it.
Well, how about neodymium magnets?
No.
Okay. These were invented in 1982, and they are very important because they are the strongest permanent magnet known. And so apparently a neodymium magnet can lift 1,000 times its own weight, which I think is pretty impressive. Well, they call them neodymium magnets, but in fact they're not made of pure neodymium. In fact, they're not even made mostly of neodymium. It's an alloy having the formula Nd2Fe14b. So we've got neodymium, iron and boron in there, and in fact we've got way more iron than we do neodymium. However, they still call them neodymium magnets. What do these find uses in? Pretty much most electronic devices that require magnets, so things like speakers, headphones, hard drives, guitar pickups. And in fact, right now we're probably talking into something that has got neodymium in it, microphones.
Well, hello in there. Lovely to have you on the show. Glad you could join us. On the subject of magnets, can you get fridge magnets that are super magnets?
Yes, indeed. You can get
yes.
super strong fridge magnets that probably won't come off once you put them on. You can buy bulk packs of them online very cheaply on popular online stores.
Is there nothing you can't buy?
If you're really interested in these neodymium magnets, have a look at YouTube. And there's clips all over there. And honestly, if you take them apart and then let them come together and put your hand between them, they'll take your fingers off. They're really, really strong.
Don't try this at home, people. Don't.
And because, again, they're useful as magnets, so in an average electric car, we have got a kilo or so of neodymium. So we've, got neodymium sitting in our garages.
Fantastic. These are all quite new uses. What did we first use it for?
Nothing probably as useful as the magnets, but way back when, neodymium was a component of a thing called mish metal. We met that in the lanthanum episode, and that's used in flints in cigarette lighters. What else? We've got a thing called didymium glass. So didymium, that element that wasn't an element. What we find is if we put neodymium and praseodymium in glass, we get a thing called didymium glass. And that's used in welders' goggles to protect from both visible and infrared radiation. Now, really interestingly, so there are some neodymium compounds that have the property that they appear different colours to the human eye when they're illuminated with different types of light. So, for example, fluorescent light versus ordinary daylight. So this also occurs when you incorporate neodymium compounds in glass, and so the glass can actually appear red, purple, or blue, or green, depending on the type of lighting, which I think is really cool.
That's amazing.
It is. Very, very nice. Neodymium, very, very important in lasers. So there's a thing called the Neodymium YAG laser, and that stands for Neodymium Doped Yttrium Aluminium Garnet.
Yep.
And very, very, very widely used. So this is an infrared laser. So it lasers at 1064 nanometers. And it is used extensively in medical procedures such as eye surgery, for treating skin cancers, and also, funnily enough, laser hair removal. We also find neodymium YAG lasers to be very, very useful in biological systems where you want a gentle laser, I guess. And you can actually build things called optical tweezers using a neodymium YAG laser.
I've heard about those. You can move individual atoms around with them, I think.
Yeah, pretty much. And what you can do is that you can sort of, in inverted commas, hold particular microscopic particles with the laser beam. So you can hold them in one place or you can move them or whatever, and it doesn't damage the biological sample. So really quite astonishing stuff.
That's such precision. That's incredible. What's today's interesting fact?
Well, if ever you've had a green laser pointer in your pocket, that operates also thanks to neodymium. The reason being that your neodymium YAG laser lasers at 1064 nanometers, which is in the infrared, which we can't see. But if you do a thing called frequency doubling, that means you halve the wavelength to 532 nanometers, which is a beautiful green colour.
Ooh, and that's neodymium. We hope that you're finding that the Elemental podcast is exerting as strong a force over you as a neodymium supermagnet.
So to find out more, check us out at rnz.co.nz/chemistry or subscribe to us as a podcast.
Next time we are looking at neon. But until then, thanks for your company and goodbye from me, Alison Ballance.
And me, Allan Blackman. Mā te wā.